Fikri Muhyiddin. I'm from SR11348. So today I'm gonna talk about chapter 9, which is concept in linear and angular kinetic. So for the first one is basic concept related to kinetic, which is there are inertia, mass, weight, pressure, volume, density, specific weight, torque, and impulse, which is all of these concepts provides a useful foundation for understanding the effect of force. So for the first one is inertia, which is means resistance to action or to change, and the mechanical definition is resistance to acceleration. So basically, the property of a body or object that resists change in the body motion in any direction. So for example, I can give you a skater gliding for a smooth surface of ice has a tendency to continue gliding in a straight line with a constant speed. So no units measurement, the amount of inertia a body possesses is directly proportional to its mass. So the second one is mass. Mass simply means a substance or matter. So mass is common to all material things, whether solid, liquid, or gases. Okay. So the third one is mechanical quantities, which is force. So force can be thought as a pull, push, or blow. So by actual contact or the pull of the Earth's gravitational attraction on a body within its field. So a force is something that causes or tend to a change in motion of shape of an object or body. So the next one is center of gravity. So center of gravity, we can call it also as center of mass, the point around which the body weight is equal balance no matter how the body is positioned. So in a kinetic perspective, the location of the center of mass determine the way in which body respond to external forces. So this one is weight. So weight, basically weight represent the Earth's gravitational force pulling on the object, and vice versa, the pull of object on the earth. So basically weight is a force and mass is not. So why I'm telling you why weight is a force, it is also basically weight is also characterized by magnitude, direction, and point of application. Okay. To be technically more correct, weight should be identified in Newton and masses reported in kilogram. So this one is pressure. So pressure can be defined as force divided by a given area. So the unit of pressure are N per square centimeter. So the next one is volume. So a body volume is the amount of space that is occupies in space have three dimensions: width, height, and depth. So to get volume, you can calculate in these three things: length times width and time height, width time height. Okay, and then density. Density combines the mass of a body with the body volume and defined as a mass per unit of volume. Okay, so basically density we can collect it by mass or volume. So the next one is torque. what is taught when a force is applied to an object, either translation or general motion may result. Applied force directed parallel to the desktop and through the center of the object. So the object will be translated in the direction of the applied force. Okay. So this one is impulse. So the product of force and time over which the force act. And then let me tell you about the symbol and metric unit. For mass, symbol M and metric unit kilogram. Force, symbol F and metric unit N. So and then pressure, symbol P, and then metric unit is PA. And then volume, symbol V, and then the metric unit is liter. So density, we can use it and symbol as P, and metric unit is in kilogram. Specific weight also we can use Y in symbol, and metric unit we can use N. Okay, and then torque we use T, or instead of that it's N negative M. Okay, so the next one I want to talk about vector algebra. So vector is a quantity that has both magnitude and direction. So it represented by arrow shape symbol, which is force, weight, pressure, torque are kinetic vector quantities, and also displacement, velocity, and acceleration are kinematic vector quantities. So scalar quantities possess magnitude but no have particular direction associated. So it is start with mass, volume, length, and speed. So vector composition, the operation when vector are added together. The composition of two or more vectors that have exactly the same direction result in a single vector that has a magnitude equal to the sum of the magnitude of the vector being added. Okay, so resultant vector, the single vector resulting from a composition of two or more vector. So two vector oriented in exactly opposite direction are composed. Okay, so I can give you an example. Tip to tail method procedure may be used which the tail of the second vector is placed on the tip of the first vector. So mechanical loads on the human body, which is comprehensive force or compression, tensile force or tension, and then shear force. Okay, shear force is act parallel or tangent to a surface. Okay, so compression, pressing or squeezing force direct axially through a body, and tension, pulling or stretching force directed axially through a body, and then for shear, force direct parallel to a surface. So for torsion, bending, and combined loads, so complicated type of loading we call it as bending, and then torsion is occur when a structure is caused to twist about its longitudinal axis, typically when one of the structure is fixed. So the presence of more than one form of loading is known as combined loading. And then for bending, usually asymmetric loading that produce tension one off side of a body longitudinal axis and compression on the other side. Okay, torsion, load producing, twisting of a body around longitudinal axis. Okay, so tools for measurement kinetic quantities. The first one we have electromyography, and then dynamography, then gate analysis laboratory, and that's all. Thank you so much.